friends, I welcome you all in this session. As you are aware, in previous session we discussed about design of experiment and analysis of variance. In this session we will continue our discussion on analysis of variance. So, let us look at one way ANOVA, one way analysis of variance. As I have already told you that one way analysis of variance is used for analyzing completely randomized design. So, null hypothesis is that all populations means are same and they are not same is alternative hypothesis. So, let us look at these three distributions 1, 2 and 3. So, these are three distributions having same mean, right. So, we want to know, are these means same or is there any significant difference amongst these means? So, that is to be tested. We are not bothering anything about variances or standard deviation, we are bothering about means only. So, this is how you can represent these three distributions. So, null hypothesis, the null hypothesis is not true if at least one of the means is different. So, let us say if mu 1 and mu 2 are equal, let us write mu 1 and mu 2 are equal, but mu 2 and mu 3 are not same, we will reject null hypothesis. Or you may have, let us say mu 1, mu 2, mu 3, all three are different from each other. Okay. So, this is how you can represent distribution. So, these two means are same, but this mean is different, but all these three means here are different from each other. So, as I said, there is something called total sum of squares, which is nothing but the summation of these two. It is the among group sum of squares and within group sum of square. So, total variation, it can be partitioned or can be split into two parts using one way ANOVA is accomplished by partitioning the total variance, and this total variance is nothing but among group variance and within group variance. Okay. So, this is total sum of square, which is sum of among group sum of square and within group sum of square, right. W stands for within, A stands for among, right. So, total variation is the aggregate variation of the individual data values across the various factor levels. Among group variation, variation among different groups, right. So, let us say there are three groups. So, difference among first, second, third and first and third. Within group variance, you will always have some variance within column or within group, because you will always have certain elements in each group and there would be some variance within those elements. So, that is called within group variation. So, total variation is sum of variation due to factor and variation due to random error, right. So, this is unexplained variance and this is explained variance, is not it. That is what we have discussed earlier as well. So, total sum of squares can be calculated like this. It is the summation of all j ranging from 1 to c, all i's ranging from 1 to nj. Here nj is number of observations in each group j. Xij is nothing but ith observation for jth group, x double bar is grand mean, right. So, c is number of groups or number of levels. So, this is how you should be calculating total sum of squares. So, total variation, let us say if there are three groups and these are different observations in these three groups. So, first, second, third, fourth, first, second, third, fourth, right. So, three observations in first groups, 4 observations each in group 2 and group 3. So, this is how you can calculate total sum of squares. So, first of all you would be calculating group mean of all these 3 groups, and then this is nothing but grand mean, right, x double bar, which is this line. Okay. Let us look at among group variation. This is how you can calculate among group variation. So, this is Nj is number of the sample size from group J, Xj is sample mean from group J, x double bar is grand mean, and C is number of groups, right. So, if we know among group variation and if we know within group variation, we can add these two variations to get total sum of squares. So, this is among group variation. Now, this is how among group variation looks like, right. So, there is one distribution, right, its mean is this. Okay. Another let us say there is one more group whose distribution is this. So, this is the mean of second group. So, this is among group variation, right. This is what is the variation between these two groups. Okay. So, mean sum of square, mean square among is sum of square among group divided by C minus 1. Here C is what? Number of groups, right. Okay. So, this is how among group variation looks like, or between, in this case since there are two groups, we will call it between group variation, right. If you have got more than two groups, we will call it among group variations. So, this is among group variation. So, among group variation would look like this. So, you have got 3 elements in first group. So, this is the mean of first group, and how that mean is away from grand mean, right. So, this is the difference, this the difference, and this the difference, right. So, this is among group variation. Okay. Let us look at within group variation. So, for within group variation, this is the formula you can use, and all these terms are there, we have already defined them. So, within group variation, and this is how within group variation looks like, right. So, this is the variation within group, and among group how it was. So, this is among or between group, and this is within group. For example, this is within group variation, right. Okay. So, the mean square within can be calculated by this formula, right. Within group variation, so these are different elements. So, variation from mean of each element, the variation of each element from mean of the group. So, this is the mean and this is the difference. This is the mean of second group, and these are the variation from mean of each item or each group member. Similarly, for third group. So, this is how you can calculate within group and among group variation, right. So, the mean squares are obtained by dividing the various sum of squares by their associated degrees of freedom. So, the degree of freedom for total is n minus 1, for within group it is n minus c, and for among group it is c minus 1. Okay. What is c? C is number of groups, right. So, this is how the one way ANOVA table looks like. The output from, let us say, Excel or Minitab or any other software. So, you will have degrees of freedom, sum of squares and mean square, and then F statistics. So, F statistics is nothing but is the ratio of among group variation and within group variation. So, we will always compare among group variance, among group and within group variation, and we will see whether this F statistics is within rejection region or acceptance region. Okay. So, we have already talked about this DF is degree of freedom, right. So, F statistics is ratio of among group to within group with these degrees of freedom. So, if you look at F statistics or F distribution is always one tail test, keep in mind, it is not a two tail test, it is always one tail test. So, this is your rejection region in F statistics and this is non rejection region, right, this side, this entire region is non rejection region. So, the F statistics is the ratio of among group and within, among estimate of variance and within estimate of variance, and the shape of this distribution depends on the number of degrees of freedom of numerator and denominator. So, let us say this is shape of distribution. If you increase numerator degrees of freedom and denominator degrees of freedom, then this shape would approach normal distribution, right, it would become a normal distribution. So, the ratio must always be positive, and the decision rule is this: if this is your critical value, if critical value is let us say less than, or if critical value is less than calculated value, and if it is in this region calculated value, then we will reject the null hypothesis. If it is in this region, we will not reject null hypothesis, right. So, we will not reject null hypothesis if F statistics is greater than alpha, right. So, this is how the shape of F distribution changes with change in degree of numerator of with the degree of freedom of numerator as well as denominator, right. So, this is the shape of the curve, right, for 1 degree of freedom numerator and 3 degree of freedom denominator, right. So, the first one would always be for numerator and the second one is always for denominator, right. So, just see how this shape is changing, right, with change in degree of freedom of numerator as well as denominator. So, let us look at this question on analysis of variance. So, let us say there are 3 different teaching methods M1, M2 and M3, and these are the marks of 5 students when they were taught by using method 1, marks of 5 students when they were taught by method 2, and these are the marks of 6 students when they were taught by method 3. Now, the question is there significant difference in effectiveness of these 3 teaching methods? So, how would you frame null and alternative hypothesis? So, first of all, you will say that mu 1 is equal to mu 2 is equal to mu 3, right. Mean of method 1, method 2, method 3, all these are same. So, this is your null hypothesis, right. Alternative hypothesis, they are not same, right. So, let us say mu 1, mu 2, mu 3, they are not same, or at least one of them is not same. Okay. So, first of all you need to find out among group variations and within group variations, right. Let us look at this question. So, first of all we will find out among group variation, right, or sum of squares among group, because there are 3 groups, we will call it among group. So, among group variance are column variance, right. So, first of all what you should do, find out the sample mean of each of these groups. So, summation of all these is, you just add all these 5 numbers divided by 5, you will get 17, here 21 and here 19. After finding out mean of each of these groups, find out grand mean, which would be mean of these 3 means. So, 17, 21, 19 divided by 3. So, 19 is the grand mean, and we have to test this hypothesis at 0.05 significance level, right. Now, let us calculate among group variance, right. So, first is sample mean of first group, sample mean is this, sample mean is grand mean, sample mean minus grand mean is minus 2, 17 minus 19 minus 2, 21 minus 19 plus 2, 19 minus 19 0. So, sample mean minus grand mean, take the square of this column which is 4 4 0 and multiply this by the sample size or the number of units in each of those samples, right. There were 5 units in first sample. So, 4 into 5 20, 4 into 5 again 20, then 6 into 0 6 and the total. So, this is what we have written here, summation of Nj, right. Nj is the number of items in that particular group, right, into mean minus grand mean whole square, right. So, this is 40. So, SSI is 40. So, between column variance would be just divide this by C minus 1, here C are nothing but number of columns, right. So, there are 3 columns, 3 minus 1 is 2. So, that is why we are dividing 40 by 3 minus 1 which is equal to 20. So, we have calculated between column variance. Now, let us look at within column variance. For within column variance, this is the formula you have to apply, but let me tell you how to find out within column variance. Now, when I say within column means in column itself, right, between column means between these 2 columns, right, M1 and M2, between M2 and M3, right. So, this is this between column and this within column, right. So, we will now find out within column variance. Since we know the mean of first group which is 17, so the first element in first group is 15, second element is 18, third 19, fourth 22, fifth 11. So, subtract sample mean from each of these elements and take a square of it. So, this is 4, 1, 4, 25 and 36, add all these, right. So, this is what xij minus x bar j whole square, which is this, summation of this is 70, right. Similarly, for second column, the sample mean of second column is to be subtracted from all the elements of second group or second column, take square of it and summation of it. So, 62. Similarly, for M3 or third group it is 60, right. So, now the variance is 70 by 4. Why 4? Because there are 5 items, right. So, 70 by 5 minus 1, this is 62 divided by, there were 5 members are 5 units in group 2, right, 5 minus 1, then 60 divided by how many samples here, 1 2 3 4 5 6, right, 6 minus 1, right. So, 70 by 4, 62 by 4 and 60 by 5. So, this is 17.5, 15.5 and 12. So, within column variance would be like this, it is 4 by 13 into 17.5. Why this 4 by 13? 13 is its 4 plus 4 plus 5 is 13, right. This 4 and this 5. So, total is 13. So, 4 by 13, 4 by 13 and 5 by 13. So, 4 by 13 into this, 4 by 13 into this and 5 by 13 into 12. So, this is how you would be getting as within column variance. So, between column variance was 20 and within column variance is 14.769. So, the F statistics or F value would be 1.35. So, this is the calculated value of F. Now, this is here, right. Now, we want to find out F critical. So, this is to be we will have to check F table for F critical value, and we have to check F value at 3 minus 1 degree of freedom of numerator. Why 3 minus 1? Because there are 3 groups, right. So, number of groups minus 1 is equal to 2, and for denominator what we want? It is 16 minus 3. How come it is 16? There were total 16 members in these 3 groups, 5, 5 and 6, right. We will check it again, right. 5, 5 and 6. So, the total 16 minus number of groups, and this is number of groups minus 1. Okay. So, 2 degrees of numerator and 13 degrees of freedom of denominator, right. So, let us look at table. 2 numerator. So, we have got this F table, right. So, you have got degrees of freedom for numerator, degrees of freedom for denominator. So, at 2 degrees of numerator, 2 degrees of freedom for numerator and 13, right, 13 degrees of freedom for denominator. So, this value is 3.81, which is here 3.81. So, the calculated F value is in non-rejection region. We will not reject null hypothesis. So, our conclusion is we will not reject null hypothesis. And what was our null hypothesis? That all these 3 means are same. So, we will say that all these 3 methods are equally effective. There is no significant difference amongst these methods. Now, let us look at the same question using Minitab. So, we will solve this question using Minitab, and we will see the critical F value, we will look at p value and so on, right. Okay. So, we will go to Minitab software. So, we will go to stat, we will go to ANOVA, we will go to one way ANOVA. So, response data are in column for all factors, or response data are in separate column for each factor. Okay. So, we will do data entry. So, this is M1, M2 and M3. Fifteen, 18, 19, 15, 18, 19, 21 I think, yeah, 22, 11, right. So, this is the response values, dependent variable values for first method, then 22, 27, 18, 22, 27 and 18, then you have got 21 and 17, 21 and 17, right. But for the third one we have got 6 elements, right. So, 18, 24, 19, 18, 24, 19, and then we have got 22, no, we have got 16, 22 and 15, 16, 22 and 15, right. Let us look at, we have to test this hypothesis at 0.05 significance level, right. So, let us look at how to enter this significance value. So, one way ANOVA. So, response data are in separate column for each factor level. Okay. Okay. So, we will select these 3. So, select response 1, 2 and 3. We will go to options. So, confidence level is 95%. The type of confidence interval is just click over here. So, it has to be an upper tail test or in fact. So, let us look at it two sided. Okay. Let us look at results, what results we are looking for. Display, okay, simple tables we want. So, we want all these things, right? We want means, we want ANOVA, model summary and everything we are looking for, right. So, we will click OK. Okay. So, if you look at this table, in fact, we will not analyze much this table, we will just look at p value. So, if you look at p value here is 0.292, 0.292, 0.292 and alpha is equal to 0.05. So, p value is not less than alpha. So, we do not reject null hypothesis. So, you are getting the same answer either you do it manually or you do it through Minitab software. So, this is how you can solve this question. In next class we will work out this example using Minitab software and we will try to read some more information from Minitab output table. So, for the time being let me stop here. Thank you very much.